Hello guys, welcome back to my channel, Maison African Motives. Still working on engineering science N2. So I'm having the question paper which was written in June 2022 for engineering science N2. So actually it's a scanned paper, so I don't know if it is going to be clear, but that's the questions that we had. The first question, which was on dynamics. So if you're new guys, you can consider being part of the family Maison African Motives by subscribing, so that you won't miss any of the classes for engineering science N2, N3, N4, all of those ones. You can actually benefit from this channel. So anyways, let us just quickly rush through the question paper that we had. We're given to answer the following questions, which is on question 1 on dynamics. To answer the following questions in 1.1 up to and 1.5, so it's actually up to from to write only the word or words next to the question number in the answer book. So the first question is 0 comma whatever that we have there in ohm meter equals to what in a micro ohm meter. So that is a micro ohm meter, micro, and we know that micro means times 10 to the exponent of -6. That is what micro means. So for you to have this 10 to the exponent of -6, or for you to write in terms of 10 to the exponent of -6, you do the vice versa to the number, because you want to convert to micro. So you do a vice versa, you multiply by 10 to the exponent of 6, which is a vice versa, or you simply move 6 commas, which is 1 2 3 4 5 6 somewhere here, which is 0,018. So, or you just multiply by 10 to the power 6, which is the vice versa of what? Of -6. So it will give you 0 comma, we said, remember our comma is here, so it's 0,018. Or still from your calculator, you are going to obtain this if you multiply that number times 10 to the exponent of 6, which is a vice versa of this one. It is going to give you your answer in micro ohms. Then what does the area under the velocity time graph represent? So remember, the area under a velocity time graph it represents the distance traveled, which is actually the displacement. So we are talking of the displacement there, which is measured in meters. Then on 1.3, we are asked to define the weight of an object. The weight of an object. Okay, so remember, the weight is simply the force that is acting on the object due to what? Due to gravity. That is the weight of an object, which is the force acting on the body due to gravity. So, which is actually, we know that a weight is equivalent to mg. So that's it, guys, for this one, which is measured in what? In newtons. So that's your weight there for you. And the other part is define the speed. So speed, guys, is just the rate of change of what? Of distance, which is actually measured in meters per second. Okay, so that's what we have there for the speed of an object, which is the rate of change of distance traveled measured in meters per second. So I think that one is clear. Then on 1.15, we are given to convert 3,426 square millimeters into square meters. All right, so how can we do that? How can we do this conversion, guys, to convert 3,426 square millimeters into square meters? So remember, in a meter you have got 100 centimeters. So for you to have square meter, not to forget, you just square like that. So if you square, sorry, we are talking of a millimeter, so we are going to have 1,000 millimeters, not centimeters, so it's millimeters. So it's 1,000 millimeters, then you square it. So 1 square meter is 1,000 squared, which is actually equivalent to 1 million cubic square millimeters, like that. So which means you want to convert this to square millimeters, so you simply divide by what? By 1 million. So what do we have if we divide by 1 million, guys? This number, we are going to have something like this, 3 4 2 6. So we are going to have 1 2 3 4, that's 5, 6, 7, something like that. Okay, so that's gonna be 1, 2, 3, 4, 5, 6, and that's where we are going to have it, because remember you're supposed to have 6 digits after the comma. Okay, so because you have divided by 1000, so our answer is going to be 0,003426, which will be in square meters. So that's what you are having, or you simply do multiply on your calculator direct. This is just one mark, guys. So just multiply direct on your calculator there. That's it. A motorbike starts from rest. Take note, from rest, which means we're talking about our initial velocity being at 0, and accelerates 20 seconds until it reaches a velocity of 144 kilometers per hour. It travels at this velocity for 2 minutes and then decelerates until it comes to rest after 1 minute. All the motion takes place along one straight line. 1.21 is to draw the velocity time graph for this motion. All right, anyways, we have the object which started at rest in this case, so we shall just have something like this. This is 1.2. So remember, this is a distance, a velocity time graph, sorry. So we are going to have something like this. So let's just have something like this. All right, so this is what you're going to have our velocity. Remember, here we are going to have our velocity, which is measured in meters per second. Then this axis is for the time, which is measured in what? In seconds. So take note, this is a 0.0 for both time and what? And velocity. So this motorbike has to start from rest, which means our u is at 0 there, which is at this point. All right, then accelerates, which means there's an increase like that. Deceleration is like this, but this is acceleration and this is deceleration or retardation for 20 seconds. So which means there's an increase in speed, that is an acceleration. That is what we mean. So we're going to have our line like this. That's an acceleration, but this acceleration, we do not know here what is going to be the corresponding velocity. We are not given the velocity for this acceleration which occurred between from rest to this velocity, that we do not know. But what we know is that the time that corresponds according to this acceleration of 2 meters per square second, remember, that is what we are not even given. All right, anyways, we are given the time, not the acceleration, the time, okay, for 20 seconds. So this is our time here, which is 20 seconds. We are not given acceleration actually, and also the velocity, but we are given that until it reaches a velocity of 144. So we are given the velocity there, which is the final one. So this velocity can be determined because we are given it as 144 kilometers per hour, which should be converted to meters per second by dividing by 3,6, which will give us 40 meters per second. So which means this velocity here is at 40. Remember, already we have written that this is meters per second, so you just write the number, you don't write the units. Okay, then it travels at this velocity for 2 minutes, and we know our time is supposed to be in seconds. So in a minute we've got 60 seconds, and this is 2 minutes, so you have to multiply by 60, which is 120 seconds. So this actually means it's a constant. It's in a constant way of 120 for 120 seconds. So we just have to maintain this line that's constant. But now we must have the corresponding time, which is the corresponding time. In this case, we said it's 120, but we have to add because there is already 20 here. So 120 plus 20, which is going to give us 140. So this is 140 seconds. All right. Then after that, we are then decelerates, which means we are talking about this way, until it comes to rest, which means our final velocity is now at 0, just like our initial velocity, rest at 0. After 1 minute, which means we are given our time in minutes, which is we are supposed to convert to seconds. So remember, 1 minute is 60 seconds. So that is it, guys. So we have got 60 seconds in between this point until it comes to rest. So this is at rest, where it is going to have a velocity which corresponds at 0 there. So this happened, we said, in 1 minute, and 1 minute we said it's equivalent to 60 seconds. So you add 60 to this value, which is going to give you 200 seconds. So that is your velocity time graph. I think everything is there. So then what is the questions now from this part? What are the questions? Okay, the first question is to determine from the graph, which means you are using the graph 1.22 the acceleration. So you're supposed to know where this acceleration is taking place. So acceleration is taking place, this is where our acceleration, this is our deceleration. Okay, so at this point, what is our acceleration from 0 up to 40 meters per second in 20 seconds? All right, so remember, acceleration is equivalent to the change in so this was 1.21. all right, then this is 1.22. acceleration is the change in velocity over the change in what? Over the change in time, which is t2 minus t1. So acceleration, that's the change in velocity if you are using the graph like this, which is v1 here, then v2. So it's 40 minus 0. So we are going to have 40 minus 0 over the time which was taken between 0 up to 20. So it's 20 minus 0, t2 minus t1. So that's 20 minus 0, which is going to give us a positive 2, which is measured in meters per square second, or someone can write this as 2 meters per square second like this. It's still one and the same thing. So that is your acceleration. So we have got our acceleration. All right, let's move on to another question. Let's see another question, still using the same graph, because we asked to use this graph. Okay, the deceleration on 1.23, we need the deceleration. So deceleration, that is this portion. So just like acceleration, deceleration has got the same formula, but it's only that we are going to have our answer with what? With a negative, but the formula is still the same, v2 minus v1 over t2 minus t1, the change in velocity over the change in time. So this time, this is where your deceleration occurred. So this will act as your v1 and this will act as your v2, that is u and v, because this is your final velocity, which is your v2. Okay, so it's at this point, remember the velocity corresponds with the 0 because it's at rest. So that's 0 minus this velocity at 40. So that's 0 minus 40 over t2 minus t1, which is the difference between these two, 200 minus 140. 200 minus 140, like that. So this is going to give us a negative 2 over 3, which is measured in meters per square second, or as a decimal, that will be negative 0.6666, and that which is 667 meters per square second. So that's it, guys, for your acceleration, for your deceleration. I mean, that's why you see it's having a negative. It's a deceleration. It's a negative value. Then the total displacement on 1.24, the total displacement, remember we talked about this, that here on 1.2, when they asked you what does the area under the velocity time graph represent, then you said displacement. So which means that one we are supposed to know it because we actually defined it. So that one we are going to calculate the area. So this, in this case, we are saying that the displacement is equivalent to the area under the graph, which is area under the graph. This is your graph here, not this part. So we've got A, B, and C, which is a triangle, a rectangle, and a triangle. So we've got area of a triangle, half base times perpendicular height, plus length times breadth, plus half base times the perpendicular height. So that's what you're going to have, which is half of the base, that's 20, times the height, which is 40. So that's our perpendicular, which means at 90, half of 20 times 40, half of 20 times 40. All right, so that's what you have, plus length times breadth. So the length is the difference between these two. So remember, this is 20, this is 140. So 140 minus 20, which is 120 here. Then this is our breadth, which is 40. So it's 120 times 40. That's what you're going to have, plus half base times perpendicular height. You're now talking of this triangle. So this is your height, your perpendicular height, and this is the difference, 140 to 200. That's 200 minus 140, which is 60. So it's half of 60 times 40. All right, that's half of 60 times 40, like this. So there you have to combine everything properly. So the first part actually gives me 400 plus this one, which is 4,800, plus the last part, which gives us 1,200 off of this, times 40, which is going to give us 6,400 if we add everything on our calculator. So that is the displacement. So they can even ask you the average velocity, where now you are saying total displacement over the total time. They can ask something like that. So that's what we had to get 15 marks. On 2.1, you are now asked to define the equilibrium of the system of unbalanced forces, which is the equilibrium of the system of unbalanced forces, which is when the magnitude and direction of the force acting on a body are balanced, they're showing a zero net force. So actually definitions, guys, I don't know, you have got so many definitions there that you can actually use. So I don't know which one is best for you, which one is that one, which one. So on the comment section we can even know more about your definitions. On 2.2, now we are given that a light horizontal beam which is in equilibrium has a length of 12 meters and is supported 3 meters, whatever that you have. So as to make a neat fully labeled line sketch of the beam showing all dimensions and loads. All right, so we are going to read this as we are drawing the beam there, which is on 2.21. So we need to have a sketch here. All right, so sorry for that. So this is what you're going to have on our sketch here. So this line is actually 12 meters, like we are told that it's 12 meters. All right, anyways, let's see. So we've got a length of 12 meters here. We shall talk about this later on, and is supported 3 meters from the left. All right, so from the left end, and the magnitude of the support. Okay, so let's start here by 3 meters from the left end. So from the left, this is your left end. Okay, so they are saying in between from this point to this side, going this side, that is from the left going to the right, that is where we are having a support. Okay, being supported, which means this is support, and always a support faces upwards. All right, so we are going to have our support here facing upwards after 3 meters. So you've got here at this point we've got 3 meters in between these two. So we've got 3 meters there. So we can even name our points to say this is our A, B, and whatever, but this is from the left, so you can even name it L. I don't know which one do you want, name it. 3 meters from the left and on the right end. So these are the supports. It is supported from the left and also supported on the right end. So this is direct on the right end here. So this is your right end. So there's a support there on the right end. So you can just call this R. We'll see. That's what we have on the right end. We have got a support there. Then let's move on. The magnitude of the support is 3. The magnitude of the support 3 meters from the left. Okay, that support of the which is 3 meters from the left, which is this one, because remember we talked about this one, which is 3 meters from the left. We are given that its magnitude is 305 Newton. Okay, so this one, it has got 305 Newton. So we've got the magnitude of this one. All right, then what do we have? And the right end support is R. So the right end, they told us to name it R like that. Okay, the beam also carries concentrated load F. So there's a concentrated load which is now a point load facing downwards. All right, on the left end, so there is a load F on the left end. This is the left end here, but this is a point load which is a concentrated load, so we shall have it going down, facing down directly on the left end like this. So this is where we have it, and this is your F. All right, so then what happened on the left hand end? Also we have got 180 Newton, 105 Newton, which are 5 meters and 2 meters from the right end respectively. So which means this 180 is 5 meters from the right end. Okay, that is respectively. 105 is 2 meters from the right end. So this is your right end. So from, which means you are going this way. All right, you are going to the left. So from the right, you'll be going to the left. Okay, so this is where we are going to have it. This is a point load, remember, a concentrated load. So, and also in between this, we've got 5 meters here. We've got 5 meters. We are told that this is 5 meters. All right, so that's a point load that we are having in this case of 180 Newton. So this is 180 Newton like that. Then what else do we have? We are now having 105, which is 2 meters from the right. So 105 is 2 meters from the right. So this is your right. So from the right going to the left. So there is a point load which is there, a concentrated load which is there, and it is 2 meters from the right, which means here there is a difference of 2 meters. All right, so here we've got 2 meters. So what does that mean? If there is 2 meters, it actually means, okay, I don't know, where did I put another marker here so that I can clearly show what I want you to see there. All right, this is it, guys. This is gonna be like this here because there's a difference here. There's a difference in between. You've got 5, so it's gonna be 5 minus 3, 5 minus 2 here, which is 3 meters. So which means that is between these two. So I'm going to name them anyhow, just name any other points that we can, but this is a 105 Newton, this point load of 105 Newton. All right, so I think that's all we have. So that's our sketch. So everything is there, but we do not have the distance between these 2 points because it's not indicated, it's not given. But we are told that this is a light beam, horizontal beam, which is 12 meters. So we are simply going to add 3 plus 5, because from this point to this point it's what? It's 5. So 3 plus 5, which is 8. Then we subtract from this length of 12 the remaining part. So 12 minus 8, which is equivalent to 4 meters. So there is a distance here of 4 meters in between those points. All right, so we can name this A, we can name this B, we can name this C, whatever that you want. Okay, anyways, that was it. Then after that, on 2.2, the question is to calculate the magnitude of the unknown force F. So we want to calculate the magnitude of the unknown force F, which is this one. So definitely, guys, since we are given this support here of L, which is 305 Newton, so we are going to just do a vice versa in order to calculate the other part. So how are we going to do it as a vice versa? So that this 305 Newton is involved, we are going to take our moments about what? About R. All right, so this is what you're going to do. 2.22, we are going to formulate an equation taking moments about what? About R. So taking moments about R, we are going to have this condition. So as we can see, taking moments about R, this support L is going to move this way, which is we are actually going in the anti-clockwise to R. So that will be the sum of the anti-clockwise moment should be equal to the sum of the clockwise moment. So we said this L, which is 305 Newton, times the distance to R, which is here there is 4 plus 5, which is 9. So 5 plus 4, which is 9. So it's 305 times 9. 305 multiplied by 9. Okay, do we have anything that is on the anticlockwise of R? Okay, this is our R here, because we are taking moments about R. We only have this one. All these, they are moving this way. Take note, guys, this one is moving this way, which is clockwise, clockwise, clockwise again. So we do not have any. So we are going to take these ones clockwise, which is 105 back to R here. So 105, there's a distance of 2 meters. So it's 105 times 2, which is going to be 105 multiplied by 2 plus, we move on, that's 180 times, there's a distance here of 5. So it's 180 back to R, there's 5. So it's 180 times 5 plus, we move on to this 105, which is at the end here, our F. So we are going to take our F here. So take note, 105, we have taken it. 180, we've taken it. Okay, then we move on to F, which is the last one. So it's F back to R here, which is definitely say this whole is 12 meters. So it's F times 12. Okay, I think everything I have taken it. I have taken everything here. So we have formulated an equation. As you can see, this equation consists of F. So that means we are going to solve for that F. So multiply these two. We are going to have 2,745, which is equivalent to these two, just combine them at once. Okay, so F times 12, that's gonna give us 12F. Then you combine these two, open bracket multiply plus open bracket multiply, you're going to obtain 1,110. That's what you're going to have. Then you transpose, definitely here is going to subtract. So it's 2,745 minus 1,110, which is going to give us 12F, which is a 2,745 minus 1,110. So 12F is equivalent to 1,635. All right, so you can divide by 12 to find the value of F, which is going to be 132.25 Newton. So that is the value of F, which is the unknown force, 136.25. So this is 136.25 Newton. So we now have this value here. Okay, we now have this value of the force there, which was the unknown force. Now that we have it, what is the next question about? The next question is now on 2.23, which is to calculate the magnitude of the support R by taking moments about L. We want to calculate the magnitude of the support. This is the support R that we are having. All right, but taking moments about L. So so far we are given an instruction. There we are given an instruction. So we're going to take moments about L. About L. All right. So taking moments about L. Remember, L is our left side, which is the one which is this 305. This is our L here. So taking moments about L, it means this R is going to move this way. Take note how R is moving to back to L. All right, which is an anti-clockwise. So guys, the last time we actually did another way, I don't know, but anyways, we obtained the actual answer, but this was anti-clockwise. I hope someone saw this. This is anti-clockwise. This was clockwise, then this is anti-clockwise. All right, so please, I hope you corrected that one. You know, because it's supposed to be very, very important, guys. So anti-clockwise moments being equal to the clockwise moments there. So what is going in the anti-clockwise? We just have R times, you've got a distance in between back to L here, which is the same as that one that we obtained, which is 9. So it's 9 times R. Okay, so that's 9R there. So the question is, do we still have anything that is on the anti-clockwise, because you are referring to moments about this point? So let's cross check. This force here, F, is moving this way to R, which is actually in an anti-clockwise, but these ones, they are moving in a clockwise back to what? Back to L. So these two, it's clockwise. So remember guys, I said correct the movements that I was talking about on the first part that I did, just vice versa what I was saying. That's it. Okay, now I hope you understand. Now this is clockwise, this is where the clock moves, so it's clockwise, this one. So which means we still have this one which is moving in the anti-clockwise, which is 136.25 times 3. All right, so we shall add to the other one which is on the anti-clockwise, which is 136.25 times 3 back to R there, which is equivalent to, we no longer have, so we have taken back to R, back to L, which is 3 meters. So now what is on the clockwise side, the ones that are moving in clockwise, we've got 180 times 4. Remember here we say there's a distance of 4 meters, so it's 180 times 4. That's 180 times 4. Then we move on to this one, which is 105 times a distance here, it's 4 plus, remember there's 3 meters in between, so 4 plus 3, which is 7. So it's 105 times 7. That is what you are going to have, plus 105 times 7, like that. All right, so now since we want to calculate R, that means we have to solve for R, or to make R to be the subject. So that's gonna be 9R plus, you combine these two, which is 408.75. all right, so if we combine these two here, we are going to obtain 1455. Then definitely you have to transpose this, which is going to be a negative. So 9R is going to be 1455 minus 408.75, because it was a positive, so now it's a negative. So that means 9R is equivalent, if you subtract, you're going to obtain 1046.25. Then definitely you divide by 9 by 9, that will be the value of R there, which is 116.25 Newton. So that's our R there, which is this one. So you can actually prove it by taking moments, by taking forces now using the Newton's third law, F up is equal to F down. Otherwise here we are not told about that to prove, but you can actually prove by taking F up and F down. So if you add these two, this one and this one, you must obtain the sum of these three. So please, can you do that and cross check if they are corresponding? If not, then let's come back guys and work on it again until we obtain the correct answer. All right, then that's it guys. So as you can see, that's a total of 10 there, and you're done. So let's see another part that we had, which is on question 3. That's question 3 there, which is on energy and momentum. So the first part on 3.1 was to define the term momentum of an object, of which you just know that momentum is simply the product of what? The mass and what? The velocity. That's momentum for you. So that's what we had there, which is mass and velocity is the product of the mass and the velocity of an object, which is 3.2, an avocado with a mass of 150 grams. So take note what we are given. We are given a mass of 150 grams. So we have to convert this mass actually to kgs. In a kg, we've got 1000 grams. So we have to divide by 1000. So we've got a mass of 0.150 divided by 1000, which is 0.15 kgs. So this is hangs from an avocado tree. It then falls freely from 70 meters above the ground level. So this is actually the height that you are given, which is 70 meters above the ground level, like this. So definitely you've got the gravitational acceleration of 9.8 meters per square second. So here there's a difference of 70 meters in between. So the first question is to calculate the potential energy after falling 20 meters from the avocado tree. What is that going to be? So that one is simply going to be remember we were supposed to have our potential energy as mgh, but now because there is a height of 20 meters that is fallen, so we are going to subtract that. So it's going to be mgh minus 20 there, which is the mass of 0.15 times the gravitational acceleration 9.8 times the height of 70 minus 20. So that's what you're going to have, guys, which is going to give you 73.5 joules. So that's your potential energy, which is actually measured in what? In joules. All right. On 3.22 now we are given that the velocity of the avocado 15 meters above the ground. So this is 15 meters above the ground like this. This is where we have got our 15 meters here. So definitely we want to know what was the distance between these two. So it's gonna be 70 minus 15, which is 55 meters. So this is the one that we need to work with to calculate this velocity, because remember we need to calculate to have the kinetic energy, which is equivalent to the potential energy that we have. So we can use this formula to calculate v, since we want velocity. Remember I told you about this formula where velocity can be transposed to give us 2gh. So our velocity is actually 2gs or 2gh, but this h now is this height of 70 minus 15, which is 55. So it's going to be the square root of 2 times 9.8 times the height, which is 55. All right, so that's it, which is going to give us 32.83832. Yeah, that's 83291, something like that, which is, you can just convert, which is going to give us 32 to 3 decimal place, which is 833. Convert to just round off to 3 decimal places as per instruction. That's what you're going to have. So according to the information that you'll be having, that's what is important, guys. It's very, very important to know that. Okay, then we need to calculate the kinetic energy there. So let me just try and adjust here. The kinetic energy of the avocado before, take note, this is before it hits the ground. So which means we are talking about on a condition that we are having the same thing. Actually here, guys, on this, okay, before I talk about this one, on this one we could have done a lot of working here to find this. Okay, let me maybe help, because some might not understand this method. So let me just try to shift it another way. We know that if we have got kinetic energy is equivalent to half mv squared. As I said, I'm going back to this question so that some can understand another method. So what you're going to have is your kinetic energy being equivalent to the potential energy, which is at the top, EP at the top, minus the potential energy, which is going to be at 15 meters, which is above ground level. So at 15 meters like that. So this simply means we have got mgh for this height, then another mgh for another height. So you can actually factor out mg so that you'll be left with h1 minus h2. So you can have your kinetic energy this way, which is 9 mass. Our mass there was 0.15, because we converted 0.15 multiply by 9.8 multiply by h1 minus h2 now, which is the one at top minus this one at 15. So at top we're talking about the whole 70 meters. Okay, so that's 70 minus h2, which is 15. So actually you can have it like that. You obtain 80.5. Then after that, this is what you're going to have, 80.85. this is your kinetic energy. Then we know that kinetic energy, like we said, is half mv squared, so you can transpose your v to be equivalent to 2 times the kinetic energy over m. Then you can put in your square root there, so it's gonna be the square root of 2 times this kinetic energy, which is 80,8. I said 80,85 here, so it's 80,85 over the mass of 0,15. So you must be able to obtain the same velocity that we obtained from that previous question that we did, 8,833 in meters per second. So anyways, I was just saying another method, but here let's focus on the question, which is to calculate the kinetic energy of the avocado just before it hits the ground. All right, so just before it hits the ground, which part are we actually talking about? That is the question. So we know that the kinetic energy that we have, EP, is going to be the same as the one at the top. I hope we understand what I'm saying, that if you are having the kinetic before it hits the ground, that is, it is actually falling from a certain distance, so it is the same potential energy which was at the top. That is the one it is going to have as the kinetic energy before it just hit the ground, because once it reaches there, it's going to be another way. So before that moment is equivalent to the potential energy at the top. So that's our EK, which will be equivalent to EP at the top, so which is just mgh. So this one is direct. Remember, our mass is 0,15 times the gravitational acceleration times the height of 70 meters above ground. So you multiply by 70 there, which is going to give us 102.9 joules. I think that's it. So that's your kinetic energy before it hits the ground. Then on question 4, which is on work, power and efficiency, we are given that the parallel weight component of to the plane is 215. So take note, we are given the parallel weight component, which means it's an incline that we are talking about here. Something like this, guys. This is on an incline. Remember, when you are having an incline, we are given the angle there of 17 degrees. So this is where you're going to have your object like this. So that's gonna be something like this. All right, so this is actually your parallel component, okay, which we know that is equivalent to W sine theta, which is equivalent to mg sine theta. So that's our parallel component, and this is our perpendicular component, or you can write as FC, and this is your angle of 17, and this is the object which has got a mass of we are not given the mass, but we are given the angle. So this parallel component, now they are given us as 215 Newton, which is Fs is equivalent to 215 Newton. All right, then the plane is at an angle of 17 to the horizontal, and the object is moved 2,8 meters down the slope in 16 seconds. So 2,8 meters, that is from this point to this point down the slope. So we've got S, which is equivalent to 2,8 meters. All right, then what else do we have in the time of 16 seconds? So the time there was 16 seconds, or just 16s. Then the question is to calculate the following. 4.11, the mass of the object. So what is the mass of the object, guys? Where are we going to have the mass? Very interesting question if we understand how to manipulate the formulas. If you are able to manipulate the formulas, then this one was going to be an interesting question. Why? Because already mass is there here, the angle is there, so you can equate our Fs, which is the parallel component, to 215. Remember, we said our parallel component here is equivalent to mg sine theta. All right, which is the parallel component. So you can write it as Fs, or I don't know how you're going to write it. And that parallel component is there which is a 215. So 215 is equivalent to the mass that we do not have times g, we have got it, times sine theta, which is the angle in between these two, which is 17 degrees. So that's what you're going to have. So to find m, as you can see, we simply have to divide to 215 by 9,8 times sine 17 degrees. All right, so that's it. And make sure that your calculator is in degrees so that you can obtain exact values there. So your mass is going to be 75,0372, something like that, which is going to give us 37. All right, that's our mass there, which is in kgs. All right, that's it. Then we move on to the other question, which is now to calculate on 4.12, which is the work done. All right, so where do we have the work done? Which formula are we going to use there to find this work done? All right, so I want us to look at the formulas that we have and see. If I am given a force, okay, let me write the formula first. If I am given a force, definitely I'll be able to calculate work done, because force times distance, because you're actually given the distance of 2,8 which was moved. But do we have this force? Which force are we talking about? So this force that we are talking about is the one that is in the parallel component, which is mg sine theta. So this mass this force we're not going to talk about it, because already it was given this parallel component, which is mg sine theta, because that is your parallel weight component, which you said it's mg sine theta. So it's already given as 215. So we are going to have 215 times the distance which was moved, which is 2,8 meters. We multiply by 2,8, which is the distance there. So that's what you're going to have. I think so, guys. If you have it, then let me actually know, guys. Let me actually know what we are having, which is going to give us this is not it, this is something like 602, okay, which is measured in joules. So that's what you're going to have. So for maybe any mistakes in calculations there, let me also know if you see any part. Then on 4.2, we are now given the graph below represent the block lifted from the ground by a means of a chain to the top of the building, which is 60 meters high. So this is 60 meters here, so it's actually 60 at that point. So we are given that on 4.21, to calculate the weight of the chain from the above graph. What is the weight of the chain? So the actual weight of the chain is simply, we have a distance of 60 meters, so you're going to find the difference between the two. So remember these guys are the formulas and so forth. So the weight of the chain is going to be the difference between 4,500 and 3,000. 4,500 minus 3,000 over the distance, the height, which is this 60 meters. So you divide, so that because this is supposed to be in Newton per meter, so that's why you have to divide by the total height, which is 60. So this is going to give us 25 Newton per meter. All right, then calculate the total work done pulling the block by the chain. What is the total work done? Remember, if you are given a force distance graph, the work done is simply equivalent to the area of the graph under the graph, which is the area of a rectangle and the area of a triangle. That is your total work done. So I'm saying work done is equivalent to the area, which is going to give us area of a rectangle, that's length times the breadth, which is then here half base times perpendicular height for a triangle. Remember that, guys, half base times the perpendicular height. So that's it, guys, which is 3,000 from this point and this point. So we've got 3,060 here, so it's 60 times 3000. So it's gonna be 3000 by 60 plus half base times the perpendicular height. So it's half of the base. This is your base, and the perpendicular height, which meets at 90 degrees. So from this point to this point is same as this point to this point, which is 60. So it's gonna be half of 60 times the height, which means we have to subtract the two. 4500 minus 3000, which is going to give us 1500. So that's it, guys. We combine the two, you obtain your area. So the first one is 180,000 meters plus no joules. Sorry, we are talking of another thing. 45,000 from the other part. So if you combine, this is going to give us 225,000, which is measured in what? In joules. Or you can even convert to kilo if you want, because these 3 zeros simply means kilo. So it's 225 kilojoules if you want, or you can leave it like that. It's still a correct answer there, because you're not given a condition to round or to write in kilojoules or to write in what. You are not given that condition. All right, anyways, let's see the other part that we had, which is on 4.23, where we were asked to calculate the power required to lift the block at an instant when it is 30 meters above from the ground with a velocity of 8 meters. So that is what we have. So what you need is that we are supposed to subtract this 30 meters from 60, but as we can see, guys, 60 minus 30 gives us 30, so there's no difference. So it's 30 meters is going to remain as it is. Why am I talking about this? Because remember that power is equivalent to force times what? The force times the velocity. That is our power, which is equivalent to force times the velocity. But the power now, the force that we are going to have, we need the total force. So the total force is going to be 3000. Okay, we are going to have 3000 plus, now remember we say the weight of the chain is 25 Newton per meter, and we are given now the distance that we are supposed to take. This was 30 meters, not meters per second, so 30 meters, because we said 60 minus 30 gave us 30. So it's going to be 30 times, because this is Newton per meter, and we've got 30 meters, so it's 25 times that. So we are going to multiply 25 Newton per meter times 30 meters, which means if it was 40, we are going to say 60 minus 40, you multiply by 20. But here they just gave us the same answer. It's not this 30 that they gave us, it's the one that we obtained by subtracting. So take note, guys. All right, so that's it for the total force. In this case, we just have total force, which is this one, times the velocity, which is your velocity, it's 8. So you're going to multiply by 8. So that's what you're going to have. So you're going to have 3000 plus, if you multiply these two, we are going to have 750 multiplied by 8. So this bracket times 8 is going to give us something like 30,000. Okay, that's 30,000, which is measured in watts. And remember, 3 zeros there, kilo. So we shall have it as 30 kilowatts. If you want to write in terms of kilowatts, but you can write your answer as just watts like that. All right, so that's how these typical questions are being expressed and how you are supposed to answer them. So that's what you had, guys, from this question on question number 4, which is actually a total of 10 marks from that, guys. So as you can see, I don't know how you see these questions or how you view them, but that's what we had. So let's quickly move on to the mechanical drives and lifting machines, which is on question 5. Name 3 advantages of gear drive. So these ones we're not going to waste much time, guys. We know there are so many advantages and so forth, so you just take the ones that are best for you. High efficiency, transmit high torque, can also be used for low speeds. So these ones, you have a lot of them. Methods that you use when reducing belt slip. Also, we've got a lot of methods that you can use to tighten the belt, to use the belt material with a high friction coefficient to increase the angle of contact between the belt and the pulleys. So we've got a lot of things there. Then we needed to make a sketch of a differential wheel and an axial lifting machine. Okay, so I think this one, guys, we have it. So that's what we have on a differential wheel and axial lifting machine. So you're supposed to make proper dimensions and proper diameters to say this one, it corresponds to this. Okay, that's what our D1, our D2, then the major diameter like that, and effort and the load just like that. So that's what we had. Then on 5.4, that's where we are given the Western pulley system has a bigger diameter, 300 millimeters. So a Western pulley system is actually, I don't know how I can actually put it this, but we will be having something like this maybe, so that we know which pulley were we talking about, which system were we talking about. So you can draw actually much better diagrams than I do, so you can actually have it in a nicer way. So all right, something like this. Okay, and here we have got right. So yeah, so guys, like I said, you can draw much better than I do. Okay, anyways, that's your bigger diameter, so you can write it as D and the smaller diameter as D, or you can write it as S and smaller as S. I don't know how you want to present it. Anyways, so we have got a bigger diameter of 300 millimeters. So in this case, I'm gonna put it as bigger D, which is millimeters. So remember, in a meter we have got 1000 millimeters, so you have to divide by 1000, which is going to give us 0.3 meters. And the smaller diameter, I'm going to put it as smaller D, or I don't know how you're going to put it as for you, which is 150 millimeters. So divide by 1000 again, which is 0.15 meters. Also, we are given an effort of 166 Newton is applied to lift a mass of 54.082 kg. So we have got an effort in this case of 166 Newton and the mass to be lifted of 54.082 kg. So list down your information properly so that whatever that you're going to do, you can be able to answer. So why having the mass? Because we know whenever you've got effort, there must be also a load, and load is equivalent to mg, which is 54.082 times g, which is 9.8. So 54 times 9.8, that's gonna be 530.004. You round it because it was gonna be 0.036, which is gonna be 0.004 in Newton. So which means the load is there, the effort is there. All right. So anyways, let us see what we have. Calculate the following: the displacement ratio on 5.41, the displacement ratio, which means we can actually use the distance ratios using the velocity ratio. All right, so the displacement ratio, you can actually use the velocity ratio, which is equivalent. If you remember, if you are talking of this, you're going to have the effort distance, okay, over the load distance, but we do not have this, so we are going to work with diameters. And if you work with diameters, the formula, you must know the formula on the formula sheet, guys, is 2d over d minus d, or you can put it as d1 minus d2, d minus, just like that. Okay, so this is 2d, which is this, so we are going to have 2 by 0.3 over d minus smaller d, which is 0.3 minus this smaller one, 0.3 minus the smaller one, which is 0.15 in meters. Like that, you can actually have your velocity ratio in this case, which is going to give us 4. So that's 4:1, or you can just leave it like that as a 4. All right, so another question was now to calculate the mechanical advantage, and there's 2 marks for that, for the mechanical advantage. So I'm gonna keep this aside. So remember that mechanical advantage is actually equivalent to the effort over the load. So all these we have it, effort over load, and our effort, we have it from that information that we listed. Our effort here, remember it's 166 Newton. So we've got 166 Newton over the load, which is this one that we calculated from mg, and we obtained 530,004. So this is in Newton and Newton, so definitely we shall have a constant value, which is 0.313, something like that. All right, so that's our information, guys, and the efficiency of the system, which is the efficiency of the pulley system that we are given. And what is efficiency? How do you find efficiency, guys? I'm asking you, how do you find efficiency? So actually efficiency is going to be the mechanical advantage over the velocity ratio, which is the displacement ratio times 100%. So we have the mechanical advantage, we just calculate it now, 0.313. The velocity ratio, we calculated the displacement ratio and obtained a 4 in this case. So you're going to multiply this by 100% because we calculated this, our velocity ratio, which was the displacement ratio. So definitely we can have this, which is going to be 7.825, and this is too small. Okay, anyways, that's what we obtained as our efficiency there. So that's how we obtain these answers, and so forth and so forth and so forth. On 5.5 we are given a condition where we have the absolute pressure inside a car tire is, we are given the absolute pressure, that's P absolute, which is 235,56 kilopascals. That's your absolute pressure. Then what should be the reading on the tire pressure gauge when checking the pressure in the tire? What is the reading on the tire? Which means we are talking about the gauge pressure now, and we do not have this, because actually if we were given gauge pressure, like you are given density and the height, you could have calculated, but we do not have this. So which means actually this is out. So what are we going to do? We just given this, we know we have P for the air, which is P atmospheric, which is the atmospheric pressure. That one we must know, that one we are given 101.3 kilopascals. That's your why having this, because we know the relationship between absolute pressure, that is equivalent to the atmospheric pressure plus the gauge pressure. So if these are equal, therefore let us make gauge pressure the subject. We just transpose atmospheric pressure to this side, so it's P absolute, P absolute pressure, which is absolute pressure, minus the atmospheric air pressure, which is the air pressure, is equivalent to P gauge. So as you can see, we have formulated so that we can have our P gauge, because the absolute pressure is there. Make sure these are in same units, and these are kilopascals. So we are going to subtract 235.56 minus the atmospheric pressure, which is the air pressure, of 101.3 kilopascals. This will give us the P gauge, which is the gauge pressure. So our gauge pressure is going to be the resultant of these two when we subtract, which is going to give us 134.26. all right, in kilopascals. Remember, you were subtracting kilopascals to kilopascals, so your answer is going to be in kilopascals also. So guys, some of this is just a matter of playing around with the formulas and so forth. And question 6, which is on friction, explain the difference between static and the kinetic friction. So that's what I had for you for the static, when it is stationary, then kinetic, when there is movement. So you can actually have the formulas, so forth. So you see guys, you have a lot there. Name 2 disadvantages of friction. So friction, remember, we have a lot of noise that can be caused, objects being blunt, causing blunt, and so there are so many ways. Causes fluids to move with difficulty in pipes, if you're working with pipes. Surfaces, the wear and tear which are actually on each other. Okay, then define the angle of repulse. This also was on a definition where you just need to define the angle of repulse as the biggest angle that may be reached between the incline and the plane and the horizontal plane before the body starts moving freely down the incline. Before it starts moving freely down the incline. That is the most important point to note there. Okay, anyways, we are given a figure there which is actually this, I'm not sure, is it 60 or it's 80 there, but that's what I saw, like a 60, because this one someone had to scan this and give me, because remember guys, you're asking for this, so someone had to scan and give me this paper. So I don't know if this is clear 60 or 80, but I'm taking it this is 60. What is important is how you calculate your answers there. So the first question is to calculate the from the above figure the coefficient of static friction. So what's the coefficient of static friction? We know that is the frictional force over the normal reaction, which is actually, you can use the weight there as 230 because this actually opposed to each other. So which means on 6.41 we shall have this as the frictional force over the weight component, and the frictional force is there 60 Newton, the weight component is 30, so it's 60 over 230. All right, which is going to give us 0.2608 which is going to be 61. That's it. Then the angle of friction on 6.42, guys, remember that the angle of friction is taken from this tan. We can have it as tan now, tan theta, not this one, guys. We need angle, so it's tan theta, which is equivalent to the coefficient of friction. So in order for you to have this theta here, you're going to have it as tan theta is equivalent to 0.261. So that means, because this here was supposed to be theta is equal, tan theta is equal to frictional force over the weight, like that, but you can just take it here. So theta is equivalent to arctan 0.261. So arctan in degrees, make sure your calculator is in degrees. Arctan is just shift tan from your calculator, shift tan, which is going to give you 14.62787 and so on and so on, which you round off is going to be 628 degrees. All right, so that's what you're going to have, guys, is your angle there. That is the angle of friction. Then what about the mass of the object? Where is the mass of the object, guys? We have got the weight here, where we know that weight is equivalent to mg, and that's the mass we are able to obtain that from this weight component, which is equivalent to mg, by dividing by what? By g. Just dividing by g, our mass can be found, which is the weight is there, and the weight is 230. That's 230 by g over g. All right, something like that. So that means we can actually divide these two, and this is gonna give us 23,46938, which is going to change to 469. Yeah, it's not going to change, because that's a 3 there. 3 cannot change that number 9. All right, so it can't change that number. So what you're supposed to be is very, very careful about your units also. So that's what you have, and this is actually a total of 9 marks, just like that. That's a question on friction, guys. Let's see what we had on the other part. On question 7, where we're asked to distinguish between heat. So I want to distinguish between heat and temperature in terms of their definition. So actually heat, we have it as the amount of energy which is contained by in the body there, but the temperature now is just an indication of how being hot or cold the body is. So this is just, I think, a clear presentation that you're having. So then we are given on 7.2 that we have got 3 pieces of steel with a mass of 4 kgs each, with a temperature of 150 degrees Celsius, are dropped into 20 liters of water at a temperature of 45 degrees Celsius. Calculate the final temperature of the mixture, which is the combined part of the steel and the water together. So this is what we have, guys. We've got 2 things here on 7.2. We have got these steel pieces that we are having, and we also have water here. So these two, we need to list their information. So take note, they are 3 pieces and each has got a mass of 4 kg. So each, which means all of these 3 you are going to multiply, which is 12 kgs. So that's your mass, because each means 1. So if there are 3, you multiply. So your mass of steel is 12 kgs in this case. Then what we have, the temperature. Okay, then here at a temperature, which is, this is the temperature of steel, the initial temperature for the steel, which is 150 degrees Celsius. Then these are now dropped into 20 liters of water. So what does this 20 liters give? It gives us the mass. Why? Because we know that in a liter we have got 1 kg. So if they are 20 liters, it's 20 kgs. So this is the mass of water, which is 20 kgs, 1:1, so 20 to 20 again. At a temperature, this is of water, so at a temperature, so this is the temperature of water. So because we are now into water, so this is the temperature of water, which is 45 degrees Celsius, and we are given to calculate the final temperature of the mixture working with these two. So definitely there are a lot of things that we do not have, which is the specific heat capacities of these. So we need to have the specific heat capacity of steel. We need the specific heat capacity of steel, which is 500 joules per kg. So this is for steel, which is 500 joules per kg degrees Celsius. We need this, and we do not have for water, which is 4187. The specific heat capacity of water, which is 4187 joules per kg degrees Celsius. So why do we need this? Because take note, the steel was dropped into water. Take note its temperature. So it means definitely it is going to drop its temperature, and the water is going to increase its temperature. So we are going to work with Q that is lost. Okay, this is 7.31. Okay, 7.2 is just like that. We are not having as 21. Okay, so we are going to have as Q lost, which is equivalent to Q that is being gained. So it is the water that is gaining. Okay, that is gained there. So it is the water that is gaining, and it is the steel that is losing its heat. All right, so which means what is that we are going to have as the heat that you are going to have from the steel? Remember, it's going to be the mass of steel times the specific heat capacity of steel into the temperature of steel minus the final temperature, which is equivalent. Here we are talking about the water which gained. So you're going to have the mass of water, the specific heat capacity of water, but this time it's T2 minus the temperature of water, because it has gained. So we have to subtract that one. So you just substitute the mass of steel, which is 12 kgs. Take note, there were 4, so there were 3, so we multiplied and obtained 12. So it's just a matter of substitution. 12 times 500, the specific heat capacity, times T steel minus T2. So the temperature of steel is 150 minus T2. That's the one that we want to calculate. The mass of water, the one that we converted from those liters, and we obtained 20 kgs. The specific heat capacity from our information sheet is there, times T2 minus T1. T2 we do not have, but T water we have it. So T2 minus the temperature of water. So we have this one, which is 45 degrees. So this is T2. So as you can see, this is a formulated equation that you're supposed to solve. I don't know how you're going to solve it, but what you need is the answer there, which is the correct answer. So multiply this. I'm going to obtain 6,000 into 150 minus T2, which is multiply these two. I'm going to obtain 83740, which is into T2 minus 45, like this. Okay, so expand brackets, that's this times this, which is going to give us 900,000. 900,000. Okay, 6,000 times T2, which is minus 6,000 T2. All right, we move on to this. We are done here. Multiply these two, so it's this and this, which is going to be 1 here, which is 83740 T2 minus this one and this one multiplies each one, and it's gonna be, guys, these are big values, but anyways, let me just write them. 6 that's 8 3 0 0 like that. So this is 3 7, yeah, 3 7 6. Okay, so you're gonna transpose this a negative. Okay, so transpose it to the left hand side, so which means this and this will add. Okay, so these two actually add, and this will be 4 6 6 8 3 0 0, which is equivalent to, you transpose this to this side, it's gonna add to T2 here. So that's gonna give us 8 3 8 4. That's gonna be 8 4 3 4 0 3 4 0 T2. All right, so you just transpose properly, then you divide by this value here, 8 4 3 4 0 here, 8 4 3 4 0 here. So this is gonna be 55, 535091, which is gonna be 55,351 to 3 decimal places, as they've given us this instruction. But temperature normally you're supposed to put to 2 decimal places, okay, which is, if you put to 2 decimal places, it's gonna be 55,4 degrees. All right, then on question 7.3 we had a similar but different question, only that the properties that we have now a coal, 30 kgs of coal. So this is coal now, and we have got this is our coal and this is our water. So we have got the mass of coal, which is in this case is 30 kgs of coal. So remember that when you're having coal, you're going to have also the heat value of coal. So it is used to heat 350 liters of water. So remember we said 1 liter is equal to 1 kg, so which means we've got the mass of water. So in this case, the mass of water is going to be 3,500 kgs, just that value as it is. Then we are given that at a temperature of 15 degrees Celsius, so this is the temperature of water at 15 degrees Celsius. All right, so on coal, remember we have got the heat value of coal, which is from our formula, from that formula sheet, which is 30 megajoules. It's actually 30 megajoules per kg. All right, I don't know if I'm not mistaken, but that's 30 megajoules per. Okay, anyways, on 7.31 the question is to calculate the amount of heat released by the coal. So this is heat on coal, which is energy, that's mass times the heat value. Okay, so the mass is 30 kgs, okay, times the heat value, which is 30 megajoules per kg. So as you can see, kg and kg will cancel because this is per, this is kg and this is over, so it's gonna be 930 times that, which is going to give us 900. Okay, and this is megajoules. All right, the final temperature of water if the efficiency is 55%. So if there is an efficiency of 55%, what does that mean? This E here is the amount of heat released by coal. So this is output. So this is our output energy, or just like power, output power, or something like that, because just like output power over input power. So this is our output energy. All right, so in order for you to know now the power that is going to be transposed to the other side of water here, is going to be 732, where we have got our efficiency, which is E out over E in. All right, then you play around with this formula. So that's our E in is going to be E out over the given what efficiency, which is 900 over the efficiency, 900 over the efficiency of so what I'm going to do is to divide that one by 100. Is just going to be 0.55. all right, so that's going to be 0.55. so 0.55. so you're going to obtain now, okay, let's simplify. It's a decimal, guys, which is 163,6,364, and definitely this will be in megajoules. So this is 163, something like that. Okay, so that's what we have, and the question is, what is the effect of pressure on the boiling point of water? How does pressure affects the boiling point if you are given a. So it depends. When it increases, actually the boiling point also has to increase. Then when it decreases, it decreases just like that. It becomes lower just like that. Okay, so that's what we have. When the pressure increases, then the boiling point becomes higher. Then when it decreases, it becomes lower, something like that. Okay, what does the saturation temperature of water mean? So the saturation temperature, that is the boiling point of water, that is what we have there. So I don't know how you're going to define it as for you, but what does the saturation temperature? That's what we had on question 8. And 8.2, name 2 ways of preventing corrosion. There are so many ways that you can prevent corrosion: by painting, galvanizing, electroplating here, not electroplating, by oiling, by greasing, and so forth. So many ways to work with. Explain why hydrogen chloride solution conducts electricity. So it is because it contains a free ion. Remember that if it got free ions, then it is free to move it because of that. So that is what we have. So a lot of things. They give an example in practice where electrolysis are used. I don't know which ones are you going to take. So many medium in batteries, accumulators, in capacitors, so many. Then draw the structure of an atom under normal conditions. So actually this one, we just need to know that we have got the nucleus, remember, which is going to be having protons and neutrons. And then we move on where we are now going to have our electrons and so forth. So there are so many ways that you can put it. So this is where you are going to have our nucleus here, which has got both this one has got both the protons and neutrons actually inside here. So you've got protons and neutrons, which are neutral charges, that is, there's no charge. Neutrons, now okay, let me just write neutral charge. Okay, then these are the electrons, actually, electrons and so forth. Guys, I think this is actually clear. Okay, 9.1, name 4 factors that influence the resistance of a conductor. If you are given a resistance of a conductor, remember we take this from R is equal to rho L over L. So you've got the type of material, that is the resistivity, which is directly proportional to the resistance. We've got the length, directly proportional, the area, which is the cross-sectional area, which is inversely proportional, and also the temperature, which is directly proportional. So these are the things that we have, factors that influence the resistance of a conductor: the length, the resistivity. So once you know the area, the formula, this one, then you just need to know that there's also ambient physical factors such as temperature. All right. On 9.2, 2 resistors, each of resistance 6 ohms, are coupled in parallel. The combination is then connected in series with an unknown resistor. Calculate the magnitude of the unknown resistor if the total resistance is 9 ohms. Okay, so we have got a series resistor which is connected to a circuit of 2 resistors in parallel like that. So that's it, guys. Maybe we've got a voltage source. We are not focusing about this, but we are given the series resistor that we are to calculate if the total resistance of the circuit is going to give us 9 ohms, provided that this is because here we are given that they are 6 ohms. They are each, take note, each with resistance each, which means this one is 6 ohms, this one is 6 ohms. Okay, so now we are asked to calculate RS, which is this one, the series component resistor, where we know that the total resistance, we can play around that formula, is this RS, which is the series resistor, plus the total of the parallel component, of which we know that the parallel component is product over sum. So many ways to calculate it. If there are 2, we can use product over sum. So it's simply 6 by 6 over 6 plus 6, which is going to give us 3. So RT, we have got RT, which is 9. So we say this one is going to give us 3 ohms. So we've got 9 for RT, which is equal to RS plus the parallel total of the parallel, which is 3. So we are going to transpose. So RS transpose this is going to be 9 minus 3, which is equal to RS. So therefore, the series resistor is 6 ohms. So that's what we have in the series circuit, our RS, which is 6 ohms. So that's what we had. And on question 9.3, which is to calculate the diameter of an aluminum conductor in millimeters. Take note, it's not just diameter, but that diameter should be in millimeters. All right, so this is it, guys. Remember that formula that I wrote before when I did this one. Okay, so here there is area. So what you're going, let's list our information first. We need the diameter in millimeters, but we are given the length of 75. The length of 75 meters, the resistance, which is 0.65 ohms, and the temperature at 20 degrees. So actually the temperature, this one is going to help us to find what the resistivity of copper at that temperature, which is, if you look at that temperature, you obtain this value 0, that will be 0.00000, and that will be 0.28. So you play around that. So since we say that resistance is equal to rho L over A, so and area is equivalent to pi d squared over 4. So we can calculate area first, then we make d to be the subject. Okay, so that's it, guys. So let's calculate area first. We can have it as RL. Here RA is equivalent to rho L, which is density times S. So divide by R here. So it means we shall have our area as this rho L, which is which is this one, guys, 0.000000028 times the length, which is the length of 75 there, over the resistance, which is 0.65. So we shall have our area, which is a decimal of 3.231, something like that. So it's going to be 231. All right, times 10 to the exponent of -6. So this is in square meters as your area. All right, you have got your area in square meters, and we said that area is pi d squared. So now let's play around to make d the subject, since we want to calculate d, and area is pi d squared over 4. So 4a cross multiply here, 4a is going to be 1 times pi d squared, which is pi d squared, divided by pi and pi. We are going to have 4a over pi. Then to find d, definitely it's d squared. You introduce the square root. So that means our d is going to be the square root of 4 times the area, which is the area, this one that we determined here. So we just write as it is, 3.231 times 10 to the exponent of -6, everything over pi. So that's your diameter in meters, because these are in meters. So we shall have our answer first in meters, which gave me something like 2.028, something like that, times 10 to the exponent of -3 if you round off properly. And this will be in meters, because these were, the area was in square meters, so definitely diameter in meters. But we are told to give this in millimeters, and in a meter we have got 1000 millimeters. So simply multiply by 1000 your answer. You're going to obtain 2.028 millimeters. If you multiply these times 1000, that's what you're going to have. So that's what we had, guys, on this question paper from the scan that we got from you guys, to make it a total of 100. So as you can see, that is engineering science N2 for you guys. So I don't know if you see any changes and anything on the comment section. We can talk there a lot. I don't have much to talk. You can talk much, so let me know from you, so that we can be able also to know the areas to work on and to revise on. So like I said, be part of the family, so that you'll be able to be part of engineering science N3, engineering science N4, and so forth. But that's what we had from Mason African Motives. Till we meet again.